Okay, so we're off and running. We are in the this is it for tonight. We're gonna wrap up. Do what we can. We'll make it as far as we can. Try to wrap up the lessons here, and then time permitting, we'll do as many review questions. If you have any questions to go over, don't hesitate to shout them out. But let's go ahead and, I guess, look at pick up where we left off. I think I know we were at 6.3, but I think we'd sort of finished 6.3 effectively because it was all about the translation, using the translation between exponential and logarithmic. But I think we were sort of done with that in terms of there's no new problems to do. So this was okay. Whoops, sorry. This was the natural log. So we were doing that. Okay, so now now I see what they're doing. So use the calculator. So this one you could just type in on your calculator a log of 1,000. By the way, oh, this asks you to do it without your calculator. So when you have just the log there, by the way, and no base, the implied base is an implied base of 10. 10. So this would actually be written more long form as log base 10 of 1,000. So how would you turn this into an exponential? Excuse me. So this would be your base, this would be your n, and it equals x. So turn this using b to the x equals n, you would get 10, 10 to the x equals 1,000. And just a quick reminder, the 10 is because they don't tell you what the base is. And so when they don't tell you what the base is, it's an implied 10. And just to kind of, I guess, finish this one up, uh, we convert the 1,000 into what? 10 to the third power. And so now that the bases are the same, we set the exponents equal to each other. And so the answer here is x equals 30. So that's how you would do it without a calculator. You would use the translation between a logarithm and an exponential. It's still sort of relying on the same thing. Though, give it a try. Try this on your calculator. You would type, if you wanted to type this on your calculator, you would type, actually, I don't know. Let me get the calculator. It's been a while since I've done a logarithm. 1, 2, 3. And it says log. Log. Yeah. So just type in 1,000 and then hit the log button, and it should pop out the value of 3. Yep, 3. So try it out on your calculator. That log button on your calculator is a log of base 10. Log of base 10.
So that's the only way we could use our calculator is if it doesn't have a base number, because our calculator on my calculator it just says log 10.
Right. um, the answer's the answer to your question is the only log you can do on your calculator is a log base 10. If you have a different base, you can still do it on your calculator. There is a way to do it. It's a formula you have to apply. It's called the change of base formula. So
Okay.
probably more on that in a second. I think they probably have that as part of. So we'll show you. I think it's. I'm not going to show you if they don't do it. If they do it, I'll show you because it
Okay.
uh, doesn't always. Just because something can be done doesn't mean that we should do it because it doesn't always help. Okay, so how are we going to do this one? It's relying on the same thing. You want to use the translation to an exponential b to the x equals n. So how would I use this translation using this expression? What's the b?
Would it
Eight.
be
B
8?
means base. That's the small number. So think of what this says. Base to the exponent. That's why I use b and x. Base and exponent. So it's intended to be a mnemonic device. So the base is the little number, which is the 8. Exponent, what's in the exponent position? So here's your base, here's your n, and this is your x. That's what I recommend on whenever you're trying to convert a log to an exponential, label the parts. And so b is the base, 2 is the exponent, and it equals the n of 2x minus 8.
And you just keep it at that. You don't simplify it.
No, you would. It wants you to solve. So you got
Okay.
to find the value of x. So that value is, oh, yeah, 36. I'll let you fill in the gaps. So, but the key here is the translation from a log to an exponential. Label your b, x, and n parts and just and fit it into the model. That's the key right here. This part of it is right there.
So 36.
Yes, 36.
Oh, yeah.
Okay, so let's press forward. Let's see where we're at. Use that Desmos for this too. Use the Desmos for this thing to graph. Um, hmm, there is a way to do it. Well, it's kind of a little tough. I'd use the Desmos more than anything. It's just it's kind of tough. So it goes through traditionally it goes through a log function. So let's say it this way. An exponential runs like this. Okay. So notice the key is that it goes through typically the base function goes through the y-intercept of 1. Now here, this sort of shifts it over. But so if this is an exponential, a logarithm would come around the other side. Let's see. It's going to do, it's going to do this. Like that. Kind of like that. So I'm not doing it justice. I can tell. I can see it. I'm doing a bad job. So the answer to this one would probably be one of these two over here. One of these two. And let's see. The answer is y. That's where the Desmos comes into play. I can't really see. Oh, now I can see it. So this one, the asymptote. The asymptote on this one is a little higher, a little lower. I mean, not really good. Let's do Desmos. Desmos. Not the graphing. Yeah.
So technically, there's not anything we can solve
Mm-mm.
to
Oh,
figure it out. You just got to visualize it.
This one's plotting points. So technically, you could remember you pick x, y values, pick values of x, and try to plot
Okay.
it. But you want to pick them in such a way that it's an exponent of x of 5 or a power. I'm sorry, a power of 5. So I would pick values. What I want this thing here. I want this thing here, the x minus 1, to be something like 5, 25, 125 powers of 5. Why? Because remember, this is going to translate to 5 to something equals x minus 1. Yeah, x minus 1. Sorry, my pen's all over the wood. So I need to pick values here that I can find the exponent of. Okay, so 5 squared is 25. So my x would be 26. So I plug in that's what I'm saying. You plug in the value of 26, you get the y value of 2. That's one set of ordered pairs. So then another set of ordered pairs would be, let's say, 6. 6 minus 1 is 5. So you pick the value of 6, and that gives you a y value of 1. Things like that is what you would do. Yeah. And then you could also pick, there's another one. You can pick 1. Nope, not 1. 2. You pick the value of 2. That gives you 1 so that y is 0. So those would be your ordered pairs. So 1 comma 0, 6 comma 1, and then 26 comma 2. It's way over here. It'd be like way over here. So maybe that's it. I don't think so though. It didn't go through 1 comma 0. It didn't go through 1 comma 0. Oh, there it is. It's that one down there. Yep, that one down there. So my point is you would do the same thing. You can pick ordered pairs, pick values of x, plug it into the function, and get your corresponding output. Just the x's that you pick, you want to pick them in such a way that the result of x minus 1 is a power of 5. So that's why you pick 26 for x, because 26 minus 1 gives you 25, which is a power of 5. That's the idea behind that. We do another one right quick. Try similar. So here, oh my goodness, I don't want to do that one. There we go. So let's pick values of x such that this whole thing here, x minus 2, will give us a number that is a power of 3. So what would be, so what are we thinking of powers of 3? 3, 9, 27, 81. So what value of x can I plug in here that will make this thing become 3? What value minus 2 gives you 3?
5.
5. So I plug in 5 for x, okay? So I'm going to do log base 3. And when I plug in 5 for x, that's going to give me log base 3 equals 3. Do the translation. 3 to the x equals 3. So what value, well, it shouldn't be x. I'm not going to, I shouldn't use x. I should use y. 3 to the y equals 3. So what value is y?
1.
1. And now you just rinse and repeat. So now you want to pick a new value of x such that this thing gives you another power of 3. Okay? What's another power of 3? 9. Okay? So what value does x have to be in order to make the inside become 9?
11.
11. So then 11 minus 2 becomes 9. Apply your translation. So 3 to the y equals 9. And so what exponent does y have to be for it to give you 9? Excuse me. What exponent does y have to be? Yeah, it has to be 2. 3 to the
2.
second power gives you 9.
Okay, yeah, all right.
So that's how you would want it if you wanted to graph it by hand. That's how you would graph it by hand. And so now you got some ordered pairs here. 5 comma 1. So that's 5 comma 1 is right there. 11 comma 2 is like way out here. This looks like it's this one right here. But that's the point is they want you to basically you're doing the same thing. You're using the log translation. Pick a value for x, apply the log translation to an exponential, or go to Desmos and graph it. Let's see if we can do it. Log base what 3? So it only does bases of 10. So you can't use Desmos. Let's see. Oh, I did x minus 2. So look at that. It kind of gave it to us. Even though the base is different, that's okay. It's the inside that really matters.
The inside that can.
So that's I probably use Desmos to help you out to identify which one you need.
Okay, so in Desmos we would put log and something
Parentheses, whatever's typed here. Yeah,
Okay.
whatever the x minus 2 part is.
Okay.
So let me just trying to see what we need. Okay. This is the same thing. It's translation. It's the translation. So you want to translate it using b to the x equals n. So remember your translation. So you have to identify your b, x, and n part. This is b. This whole thing here is n, and it equals x. So our b is 3. Our exponent is x equals the n, which is the fourth root of 9. Ideas on how we go from here. We have to find the value of x. And so remember, when we turned
PEMDAS?
it, say it again.
Do we do PEMDAS?
Not quite.
Okay.
Remember the rule when you have exponents, when you have exponentials. You want to get the bases to be the same. Because when the bases are the same, the exponents are equal. So how can we turn this thing here into something that is 3 to a power? That's what we want to do. Turn the right-hand side into an expression that is 3 to some power. Well, let's start off with the things that we do know. Can I write 9 as something with a power of 3?
Well, with
Don't
the
worry about the
base,
fourth. Don't worry about that radical yet.
right, you can do something with the base of 3.
Yeah. How would I write 9 with the base of 3?
3 squared. 3 with
Squared.
the
3
exponent
squared.
2.
Right. Okay. So we're getting there. So now convert the radical to a fractional exponent. How can I convert the radical to a fractional exponent? Remember the process?
Oh,
The m root of x to the n,
the 2, 4.
the root becomes the denominator of the fraction. So how would we do that here?
3 and 4 halves.
Say it again.
3 and 4 halves.
Close. Flip it. The root of the radical becomes the denominator of the exponent.
2, 4.
Right. 2 over 4. Oops. Maybe I made a mistake. This is x. This part is x. Now,
So it's
this becomes the root of the, I'm sorry, the root of the radical becomes the denominator of the fractional exponent.
yeah.
Now
So
the bases are the same, and so we can set the exponents equal to each other. So x equals 2/4, or simplified as a fraction, simplify the fraction to get what?
1/2.
1/2. That's the answer.
So your answer is 1/2.
So this first step was translate from a log to an exponential. Then the goal is to try to get the bases to be the same, so that when the bases are the same, we can set the exponents equal to each other. So that was the mission here, was to get the bases to be the same. And as part of that, we had to remember the translation of roots, radicals, to fractional exponents.
I used Desmos and it came out with 0.5.
Yep.
I typed in the entire thing
There you go. See,
and it came out with 0.5.
Desmos can help too.
Yeah.
Good. I'm glad Desmos is there, because that's a helpful thing. So now it's just more of the same. Translate the log to an exponential. Once you get that, you solve the resulting expression or equation.
And then just solve for x.
And then find x, right. So it's just more that now it's just it's a repeat at that point. So let's move forward then. Let's see what we got. Logarithmic properties. Now this is the big deal. This is the thing that we wanted to really get to. Because what they're setting you up for is once you learn the properties of logs, then you can use that to solve equations. Okay. So, oh wow, we got a lot here. Whoa. Oh, now I know. Okay. There's a couple different properties. Let me pull up a Word document. This will be my whiteboard, if you will. Let's see. Okay, switch screens. Okay, so there are a couple properties. Remember the properties of exponents. It's actually pretty related to that. Remember the properties of exponents: the product rule, the quotient rule, the power rule. Properties of exponents. It's a good little refresher. Okay, product rule, quotient rule, power rule. So remember, this rule said what? When you're multiplying the same base, there we go, you combine them to add the exponents. Okay, that's how we would write it as a rule. This one said, if you divide the same base, you combine them by subtracting the exponents. And the power rule says, if you have a power of a power, then what do? You multiply the exponents. Guess what? The logs work. Remember, logarithms and exponentials are inverses of each other. So there are properties of logarithms, and they work the inverse. And so you have the product rule, quotient rule, power rule for each of those too. So you have, I'll just do this, the log of A times B gives us log of A plus log of B. When the log of the product becomes the sum of the logs. And let me stop briefly here. This is what it means to be inverse. See, we took the whoops. It's similar to, let me see. Yeah, A times B is plus, right. No, I know this. Okay, yeah, so you take the when you multiply the two, it turns into the sum. Turns into the sum. And so we could probably see, you may be able to see when we divide logs, we subtract. When we divide logs, we subtract. They kind of work in the same process. So, oops. So this one's going to say when you take the log of a fraction, you will subtract. It becomes the subtraction of the logs, log of the top minus log of the bottom. And then this one says when you take the log of something with an exponent, what do you see? Then you take the c and you pop it out in front. And becomes log of a. So c, this exponent, pops out and moves to the front and becomes multiplication. So these are the basic properties of logs, the basic properties of logs. There are other properties, other ones too, but they're more rooted in the actual translation and whatnot. We'll talk about them in a second. I guess I'll do this. There's another one called the identity property. That's what I should probably say, not rule, but property. Property. The identity property says if the base and the number are the same, then it reduces to 1. It reduces to 1. And then the 0 property is a log of whatever base of 1 is equals 0. So these are the main ones. So here, this one, the identity property says when the base and the number are the same, then it reduces to 1. Then it reduces to 1. It says when the number is 1, then it reduces to 0. It reduces to 0. So let's see some of these in action. Let's see some of these in action. So let's see if I can do it. So let's do the log of 5x. 5x reads what? 5 times x. So we would break this up into the log of 5 plus the log of x. Just break up the multiplication and give them each their own log. So what does the log of 100p? Let me do it. Here we go. 100p. What does that become? Take the expression, multiplication, break it up, and give them each their own log. So this becomes what?
The log of 100 plus the log of p.
Right. Log of 100 plus log p. But you have to see, before you stop, can you simplify any further? Can you simplify this one or this one any further? The answer is yes. How do I know? What's the base of this log? If I don't tell you, it's a what?
10.
10.
Does that mean the base of the one we did above is also 10?
Also 10, right. But I did this one on purpose because look at this number. If that is an exponent of your base, if it's a power of your base, that's how you know you're going to be able to simplify further. So you look at your base and then look at your number part here and say, hey, are they powers of one another? Because if so, you can simplify. You can simplify. So how would this simplify? Well, the log of p doesn't change. The log of p doesn't change. So you're off by yourself. And we don't have to write the 10. But over here, with the log of 100, how would we do that? Well, you got to use you got to maybe come over to the side here, translate this. Translate this. Okay? How do we translate? Remember the translation. So log of 10 of 100. Well, that's the base, that's the exponent of the number, and then that's equal to something. Okay? So 10 to the x equals 100. What does that x have to be then?
Mm.
10 to what power gives us 100?
2.
2. And so this thing here simplifies to 2. And Desmos can help you with that too, by the way. Anywho, so you do have to, and that's why I did this one on purpose, because that problem that we're looking at on the screen, the other one will have a simplification. So you need to check and see, can your logs, when you may apply the property, but you still have to check to see, does the log, do any of these log expressions simplify? And the way that you tell is you look at the base and you look at the number part. And if they are exponent, if they're powers of each other, that's how you know that they can simplify. That's the giveaway.
So what we're doing right here is simplifying. And the answer is 2?
The whole thing. 2 plus the log of p.
2.
What we did is we broke this up using the product rule and gave them each their own log expression. Oh, whoops, different one. We broke this one up, gave them each their own log expression. Then we asked ourselves, hey, this one can simplify. So let's simplify it, and it simplified down to 2. So let's take a look at another property. Whoops. So let's do the log of x over 4. How would you use the quotient rule, the quotient property? You give the x and the 4 their own log expression, log of x and log of 4. And then because it was division, you put subtraction between them. Just like in the quotient rule of exponents, you subtract. The division becomes subtraction. So here it's the same sort of thing. The log of the fraction becomes log of the numerator and denominator with a subtraction in between. So with that in mind, let me give you, well, I'll just keep it simple. How about log of 2/3? How could we write that using these properties?
Would it be log of 2 minus log of 3?
Yep, that's exactly right. Log of 2 minus log of 3, right? Numerator minus denominator. Cool thing is you can do that on your calculator too, but that's not what we want you to do. Okay, and then finally, the last proper, well, the last main property is the power rule. So the power rule says if you have, oof, sorry, my handwriting went bad. So let's take y to the 6th. What the power rule says, when you have an exponent inside, you look at the number, the n part, the y to the 6th, because there's that exponent of 6, what the power rule says is you take that exponent and you position it in front. Take that exponent and position it in front. And so it becomes 6 times the log of y. Now we don't have to write that times. We just write it as 6 log y. The implication is that the 6 is multiplying the log of y. So let me give you one.
How would we solve that? Or that's the answer.
No, that's it. That for this one, it's just trying to apply the property.
Okay.
So suppose I give you something like how would I apply the power rule property here?
Would we put the 3 in front of log and then 4
4.
after it?
Uh-huh. That's it.
Oh, okay.
So this is just the mechanics of applying the rules, the different properties. Any questions on the actual mechanics part? The cool thing is that these rules also work in reverse. These rules also work in reverse. And that's sort of necessary for the next lesson, which we may or may not get to, but you may be presented with that here. So suppose I have the log of x plus the log of 2. You can also use the rules to combine the expressions. So when you're taking 2 logs and you're adding them, you can collapse them into one log that multiplies the 2 values. So we take the x and the 2 and we multiply them to give 2x. So the rules work in reverse too. When you're adding 2 logs, adding 2 logs of the same base, you can join them together and multiply the end parts. Similarly, let's suppose you're subtracting log of 10. Oops, well, I'm going to not do 10, 15. Log of 15 minus log of 5. I can join them together into one log expression. But what am I going to do with the 15 and the 5? Because it's subtraction in the middle, I divide the 15 and the 5. And if you can simplify the fraction, you want to go ahead and do it. That's the answer for that one. So all these rules go hand in hand, go work in both directions. And then finally, suppose I have, I don't know, -2 log of x. I can use the power rule to take this -2 and bring it back as the exponent of the x. So that would give me log of x to the -2. That's funny. So the point here is you learn the rules one way, the rules apply the opposite way too. And the reason you would do this, why would you want to go in reverse, is because this is a way to get the log by itself, to clean it up and get the logs together. Because when you go to solve equations with logarithms in it, you want one log expression and you don't want any numbers in front for reasons we'll see in a second. But I just want you to know that the properties can go both ways. So with that in mind then, let's go back to the problem here that kind of spurred this whole thing. Here we go. So there's a couple different properties at play. What's one property we could apply? And the basic ones are product rule, quotient rule, power rule. Product is when you're multiplying, quotient's when you're dividing, power rules when you've got an exponent. So one quick rule, if you can apply your product rule first, if you got multiplication, apply the product rule first. We do have multiplication. 16x to the 8th is what? The product, the multiplication of 16 and the x to the 8th. So we can break that up into a log base 4 of 16 plus a log base 4 of x to the 8th. Now, can I apply another property? Because we don't like exponents inside. We don't like exponents inside. So if you got exponents inside, take it and plop it in front. Plop it in front. So doing that would give log base 4 of 16 plus 8 log base 4 of x. Home stretch time. Now you look at your logs. When you got rid of, you broke everything apart and you got rid of all your exponents. Now you look to see, can I simplify any of the logs? And do you all see which one can simplify? And here's how you can tell. Look at the base and look at the number. Are they powers of each other? Can you raise the base of 4 to some power that gives you 16? 2. So this thing here reduces down to 2. 4 to the second gives me the 16 that's in there. That's what the log reduces down to. And then you just bring down 8 log base 4 of x. And so now this is the answer. And that's what they want. 2, 8, base 4, x. I want you to just fill in the spots. But you had to use your properties. That's the whole point. So you can use multiple properties in one. So my recommendation, apply the product or quotient rule first where you can. Apply the power rule second, and then simplify any log expressions that you can, like log base 4 of 16. Questions? All right, let's see what else they got in terms of properties. More of the same. More of the same. Oh, I see what they want to do here. So can we simplify this? And the key here, if we look at this, when you approach something like this where they want you to apply the properties of logs, you got to go through and see, how can I turn this into or make this look like one of my properties? And so that's why you want to say the words to yourself. The log of the product equals the sum of the logs. The log of the quotient, division, is equal to the difference, the subtraction of the logs. Things like that. So is this thing here a product, a quotient, or a power? Is there anything? The answer is no on all three fronts. This is not a product because it's something plus something. That's not a product. It's definitely not division either. But can we turn 16x plus 4y into the product of two things, the multiplication of two things? And the answer is yes. In other words, can we factor 16x plus 4y? Because remember, that's what factoring is. It's breaking up addition or subtraction, to give you the multiplication of two things. So can we turn this into the multiplication of two things? Can we factor 16x plus 4y? What do y'all say? That's a good review question. Can we factor that inside there, 16x plus 4y?
Yes.
What? Yes, you're right.
You can take a 4 out.
Can take a greatest common factor of 4 out. So we're going to write this as log base 4. We're going to take out a GCF of 4, and what's left on the inside when we do that?
and 1.
Say it again. 4 and y.
And yes.
So not just
Oh,
4, but
sorry. 4x
4x
plus, I'm sorry. Yeah. Plus y.
plus y. Right. So now we break it up. We're going to use, so I'm going to jump down here. Now I'm multiplying something. I have the multiplication of 4 times 4x plus y. So I can apply my product rule. So this becomes log base 4 of 4 plus log base 4, oops, of 4x plus y. Now you see, can I simplify any further? Look over here. Are the 4 and the number, the base and the number, are they powers of each other?
Yeah.
What exponent of the base will give you 4?
2.
What exponent of 4 will give you 4?
1.
1. 1. When the base and the number are the same, it reduces down to 1. But essentially what we're asking is, you look at the base and you look at this number and you ask yourself, what power of the base will give you the number? What exponent of the base will give you the number? And that's 1 in this case. Over here, can't do anything to it. Even though there's a 4 over there, it's trapped inside of a parentheses with the x and the y. So you can't break it free. Stuck in jail.
Where did we get that second log base 4? Like what? Why do we do log base 4
So
plus log base 4?
there's a multiplication between the 4 and the 4x plus y. So you give, this is one of your factors, this is your other factor. So you can rip apart that multiplication and give them each their own log expression. The factor of 4 here multiplies the 4x plus y. And so remember, it's the log of the product. When you're multiplying the log of the product, you give each of the products their own log. So in this case, the 4 and the 4x plus y are the 2 different products. And so we give them each their own different logs. We can't give the 4x plus y, we can't break that up any further because that's adding each other. We can only break it up when they're multiplying each other. What you got, Addie? I know you're not feeling it.
No.
What's
Uh,
what are you focusing on?
I don't know. I think of course, it just helps if I can find a pattern in something and see like why I'm figuring something out. But all this just seems like chaos.
Gobbledygook.
I mean, I
Yeah.
know it makes sense if you learn it,
Yeah,
but right now I'm just really lost.
it's kind of one of those things of, that's why you want to say the rule. For me, what helped was
Yeah,
saying the rule, putting the rule into words that I understood.
yeah.
So that's why you hear me say it. It sounds ad nauseum now. I'm not trying to bore you. I'm trying to
No, it's
get it in
good.
there.
I
The
appreciate
log
when
of the
you repeat
product.
things.
Huh?
I appreciate when you repeat things.
Yeah. Oh, good. So that's the thing. That tells you the rule. It says the log of the product is the sum of the logs. Look for what's multiplying each other. So it's really no rule. It doesn't. What they're testing you here on is, do you remember that when you factored stuff weeks ago, what you were doing was turning addition into the multiplication of 2 factors. That's what you're doing. And so they want you to rely on that. They want you to remember that. Oh yeah, factoring is ripping things apart, and you're multiplying those individual parts. So that's why this one's a little weird, is because you had to factor in the middle of the whole thing, which we weren't doing before. That's why I wanted to hit this one, is so that hey, you're gonna have to factor too. And so just
Okay.
remember when we did factoring, it's something times something. Now in this case, when we factored the 16x plus 4y, we pulled out that GCF
Yeah.
times what's left behind, the 4x plus
Mhm.
y. So these are two factors multiplying each other. And because they're multiplying, then we can rip the multiplication apart into their own logs. So the log of the product becomes the sum of the logs. It may just be practice too, but you want to say
Yeah.
the rule to yourself. Log of the product is the sum of the logs. Log of the quotient or log of a fraction is the difference of the two logs. Log of the power is the power times the log. Things like that. Put it into words that you can sort of understand the pattern. Is It's how I did it.
Mm.
I'm very big on talking to myself. Um,
Yeah.
when I went through college, that's how when I had to learn a large volume of information, I talked to myself because there was something one about saying it because if you can articulate it, you can probably explain it. But then two, not only are you saying it, but you're hearing yourself saying it, and so you
Mhm.
kind of get that auditory part of it too. So, anyways,
Yeah.
very big on talking to yourself. So this is one of those complicated. It's not a complicated rule, but it's one of those rules that kind of logs are weird. It's weird. So let's say it that way. So let's see what else they got cooking for us. So here's one of those ones where they want you to combine. They want you to, and they tell you here, they want you to combine. So we have to use our um, properties to do that.
Yeah.
So you only combine. So in this one's got three expressions. So you only combine two at a time. Okay. So go left to right. Go left to right.
Can I ask you a quick question?
Uh-huh.
Okay, so I know I should have asked this a long time ago, but what I'm not super great at taking notes. So what would you suggest we do for this? Should we write out what they're asking and then because like I like to go back to my notes.
Yeah.
And so that whenever I reach this again,
Hmm.
I can find out what I'm supposed to be doing.
So
But
in this one, I would probably say like combine logs. That would be my heading.
okay,
Combine logs. Then you got the problem, and then you say use properties to combine. That's probably how I would do it.
okay. Thank
I,
you.
I was a terrible note taker. I was more of a stenographer. I would try to copy everything the
Yeah,
instructor
me
said.
too. And then by the time I finish copying, I'm like, wait, what just happened?
Yeah.
Was it fine? Yeah. Okay. Thank you. So combine logs use properties. Thank you.
So before we can combine the logs into one expression, you have to get rid of the numbers in front first. So notice we have a 4 in front of this ln. Remember ln is a log base e. That's not important for this, but I just want you to know when you see ln, you're dealing with a log. Okay, so what we have to do is we have to get rid of the 4 first and the 8. Not get rid of it, but we have to move it. Okay? We have to move it. How can we move it? Well, the power rule says take the 4 and make it the exponent of that x. And take that 8, move it from in front to the exponent of the y. So this becomes ln of 5 plus ln of x to the 4th minus ln of y to the 8th. Now that the number in front of the ln, they're all ones. There's nothing in front of the ln's. It's just plain ln's. Now we can start combining, and you would go left to right. Go left to right. So when we do that here, we combine these two first. Addition in the middle collapses into one log expression. And what do? You take the 5 and you multiply it to the x to the 4th. The addition here between the ln's, between the logs, means that we multiply the numbers inside and then just bring down the ln of y to the 8th. Now we need to take care of the subtraction. So what property are we going to use there? How are we going to combine these? Any takers?
Division?
Division of what? So we're going to collapse it into one ln expression. What's the numerator?
5x to the 4th power?
Exactly. And the denominator of that fraction is going to be 8. Oh, y to the 8th. Sorry.
Okay.
Sorry. There you go. And that's the answer. So instead of ripping apart, we want to collapse together. So take care of the numbers in front, move them as exponents, apply the power rule to make them exponents of the number part, then move left to right, applying the product rule and quotient rule. Yes. Any questions on this one? All right. Press forward. So we've got the log. Use the properties of logs. Okay, now I see. Use the properties of logs to expand the expression. We want to expand it. We want to break it apart. We want to break it apart. So how are we going to break it apart? Well, you see we got log inside of a log. But they just really like to give you some stuff. So resolve the inside, break up the inside log first. Break up the inside log first, okay? So how are we going to break up the inside log? I'm going to put this one, there's an outer log here, and that's what, so how are we going to break up the inside log? Focusing on the inside part. Log of 100 to the 5x power.
Would we give both logs their own log? Because wouldn't the
Not there
first
yet.
log?
That's multiplying. Let's put blinders on.
Okay.
Forget that log right now. Oops,
Okay.
kind of colored too much. Forget this one. If you were just going to break this one up, simplify it, how would you do it?
Log to the base of 10,
Look at that exponent. What's the exponent?
5x.
Bring it in front. That's the power rule. So this becomes, you take the 5x, put it in front of the log 100. Now, in this particular one, we just so happen to be able to simplify the log base 100. I'm sorry, log base 10 of 100. Keep in mind that this is a base of 10. So are the number and the base powers of each other?
Yes.
What power of 10 will give you 100?
10. I mean, no, 2.
2. So log of 100, this part right here reduces down to a 2. And this is multiplying in front. All the while, we still have our outer log still there. More on that to come in a second. But just a quick recap. We took this exponent and moved it to the front of this log using the power rule. That's how we got this thing right here. Then we said, oh, looky there, this thing can simplify. Log base 10 of 100, type it in your calculator, Desmos, or just sort of ask yourself, what power of 10 will give me 100? And we said, oh, that power of 10 that gives 100 is the value of 2. And that's what it reduces down to. So that's how we got here. Oops. Oops. Okay. So, bear with me. Now, let's clean this part up. Let's bring the 5x and the 2 together.
So we wouldn't have the word log in front of 2?
No, not yet. We're keeping it together so far. We have not yet transitioned to the outer log yet.
But the log of 10 with 100 over 100 to the 100th power, that log we
took care of that one.
but that's what I'm saying. It doesn't have to say log of 2.
No, because the law by virtue because because uh, because 10 squared is 100, that got rid of the log.
Okay.
Remember, just sort of this part here translates into 10 to the x equals the translation to exponentials.
Okay.
That's how I got that x is 2. It's asking what power of the base gives you the number. So now here I just cleaned it up. I kind of combined the 5 and the 2 to give me 10. Now at this point, I can break this up. Finally, I can break this up and give them each their own log. Their own log.
Okay.
And so this becomes log of 10 plus log of x So I broke up the multiplication into the sum of two logs. And so now I ask myself, can I simplify either of the logs any further?
Okay, I do have a question again. Okay, so
Just one
I
second.
understand now. I'm sorry.
No, this one here can simplify. Because remember, it's a log base 10. When I don't write the base, it is a
Right.
log base 10.
Okay, that's what I was going to ask you. Log base 10 plus log of x. It wouldn't be log of 10x?
It would be log base 10.
But
But
I'm
when there's a
saying,
base of 10, you don't have to write the base. It's just plain log.
right, but I'm saying the one that we're adding to it, log of x. Where did that 10 go up at the top in the parentheses?
Right here. We broke it up. We broke up.
Oh, okay, I got it now. I see now. I see what's going on.
So now we're simplifying this one, and we ask ourselves, what power of the base of 10 will give me the blue 10?
One.
Say it again.
1.
1. And so that's what the answer becomes. Log 1 plus the log of x.
Whew. Okay.
This was a decent problem. It's complex, but it got a lot of stuff in there. So that, I mean, I like it because of that. It helps us to kind of review everything all at once. I would not ask that on the test.
Thank you.
But the point of the exercise, the point of all this is to be able to use the properties to break things apart or to combine things together. That's the takeaway. That's what you want to be able to do. All right, see what else they got. Combine. That's a combine. Break apart. They want to expand. When they say expand, they want you to break it apart. So when you break apart, so when you combine, do your power rule to get clean up your exponents, then do product and quotient left to right. Here, when you want to expand and break apart, do your product and quotient rule first, and then apply your power rule last. That's the difference between expand and collapse in terms of procedure. Now it's all the same now. It's just combining and expanding ad nauseum. Ugh. Ah, this is interesting. Okay, how would we do this one? Let's not do this one. This one. Let me do something a little different, but related. Suppose I have e to the 3 minus m, and m could be anything. I just wanted to pick a different letter. How would I rewrite this using my rules of exponents? Using my rules of exponents. Remember, those are the product rule, quotient rule, power rule. When you multiply the same base, you add the exponents. When you divide the same base, you subtract the exponents. And when you have a power of a power, you multiply the exponents. Well, guess what? Those rules go in reverse too. So look at your exponent and you see, oh, I've got subtraction in my exponent. What was that power? What was that rule of exponent where they did subtraction? Oh, it was the product. I'm sorry, it was the quotient rule. It was the quotient rule. So when I had a quotient, when I'm dividing the same base, I subtract the exponents. So if I'm subtracting the exponents, I divide the same base. So this becomes an E, top exponent is 3, bottom exponent is m. It works in reverse too. We didn't do that back then. Let me clean up my 3. That's a 3. So this one here, e to the 3 minus m, you use the quotient rule of exponents to go in reverse, make it a quotient, a fraction, where the first exponent's the top exponent, the exponent of the fraction, numerator, and the second exponent is the exponent of the denominator. So now we can approach this one. Now we can approach this one. And so, hold on a second. Okay, yeah, now I see. So just like that, you sort of just go left to right. You go left to right. So the 3 doing this part here is 3 e to the 3 and e to the 5 ln. This is just ridiculous.
Yeah.
Because it's got a lot going on in it. Okay, so you turn the subtraction. So here's kind of how you turn the subtraction into division, and you turn the multiplication into, you turn the addition into multiplication. So this one becomes e to the 3 over e to the 5 ln of x. And then the addition part here means we multiply e to the ln of y. Okay, we can break it up further, even further. This is ridiculous. This 5 ln of x, we can take that 5, and remember the power rule of logs. We can move that 5 as the exponent of the x. We can move that 5 as the exponent of the x. And so we'll take the whole thing again, e to the 3, but this time it becomes ln of x to the 5th. And then times e to the ln of y. One more rule. This is ridiculous. There's a rule I forgot to tell you.
Mm.
So when you take the base and you raise it to the log of the same base of n, that pops out because the bases are the same. It pops the n out. It pops the n out. So when the base of the exponent is equal to the base of the log in the exponent, when the base is the same as the base of the exponent in the log, it pops out the number. How do we use that here? Well, keep in mind, ln is what? A log base e. A log base e. It's ridiculous. So when you see ln, you want to think of it as log base e. So when the base of the exponential and the base of the log are the same, they cancel with each other to pop the n, the n part out. So that becomes a plain y. How does this one simplify? E to the natural log power, so e to the log base e pops out that x to the fifth. And then we have e to the third power. And so now you just collapse it all together. And so we finally get a mess. That's what we get. Y e to the third over x to the fifth. Like I said, sometimes they're just good candidates to skip. This would probably be one of them. That's a mess. That's a mess. I don't like that one at all. So I'm keeping track of these so that when I teach this class again, there are probably going to be some things I change. This would be
Can
fun.
Desmos help us on this?
I'll try.
I
I'll
was
try.
about to say, why you gotta wait? We could just start right now.
Yeah, I know.
I mean, if we just didn't get to it.
Right, right. Okay, so this one wants you to do express it without a calculator, but you can use Desmos, you can use your calculator. Just to kind of remember, it wants you to simplify. So, is there a power that you can raise 13 to get the 169? The answer is
Um,
yes.
yeah.
Is there a power that you can raise 13 to get to 169? Remember, just do the translation.
Yeah. I heard some.
The answer is 2, by the way. 13 squared is 169. That's one of the ones I memorized. No special, but you could use Desmos. It does it, I think. No, it probably won't. But your calculator won't either. That's just you have to use the translation. So it's just more of the same now.
Now, would we have to put x equals 2 because there's no x in there, the one that you just
No,
finished?
no, I didn't mean. I'm sorry, I shouldn't have put x. It's just 2.
Just 2.
It
Okay.
simplifies down to 2. Yeah. So this is just more of the same, breaking stuff apart and whatnot. So now we're not really getting anything new. We're starting to repeat. So let's see if we can look at that last one. We got one more to go. This is it. Where is it? Where are you at?
I have a question.
Uh-huh.
We started this class with 30 people in it. How many do you have now?
Hmm.
Still 30?
I don't think I lost. Maybe just one or two.
Okay.
I mean, they're not all coming to the seminars. I don't think.
I was about to say I don't see it like I see the same people come
Yeah.
regularly every day, but I don't see the other people, so I didn't know.
All right. So this is why we learn the properties of logarithms. This is why we learn the properties of logarithms because remember a couple lessons ago when you had an exponent. I'm sorry, when you had the variable in the exponent position, the only way we knew how to solve that was to get the bases to be the same. Okay, so remember, it's just sort of like as a refresher. If I had 2x equals well, that's 2x minus 1 is equal to 8. Remember, the whole strategy was to get the bases to be the same, okay? And so what we did is we turned that into, well, 2 to the x minus 1, and we converted 8 to 2 to the third, okay? And so, oh, bases are the same, so the exponents are the same. That was the way that we did it a couple uh, lessons ago. That's very limiting, though. It's because you can only then work with things that are powers of whatever base. But most problems don't work that way. Because is there an exponent that we can raise to get 900? Is there an exponent that we can raise the other base of 8 to get 997? And the answer is no. There's no power of 8 that will get us to 997. So we need another way to solve it. And this is a more general way. And what we're going to do is we're going to rely upon the properties of logs. And so remember my two rules for solving my two steps for solving equations. Any equation, and it doesn't matter if it was a linear equation all the way back in week 2, or now that we're dealing with exponentials in week 3 and week 12. What's the two rules? Do the opposite and do it to both sides. So we've seen this a few times. We can add things to both sides. We can multiply to both sides. We can divide to both sides. Later on, what did we see? We could take the square root of both sides. We could raise both sides to a power. So it doesn't matter. You can do anything you want to an equation just so long as you do it to both sides. That's the rule. So here, I want to break that exponent out of the, I want to break the variable out of the exponent position. How can I do that? Well, be strategic. We are talking about logarithms and exponentials. Have we been working with something in logs where we can break something out of an exponent? And the answer is yes. We've been using the power rule of logs. So you can take the log of each side. Take the log of each side. Oh, that's kind of a mess. Hold on a second. Let me use my pencil instead. So you just take each side, 8 to the x minus 8, and you take that 997. And all you do is just write the word log in front. That's taking the log. Okay? Why would we want to do this? Is because this exponent now, by way of the power rule, what's going to happen to it? It shoots to the front and breaks out of that exponent spot. It breaks out. That's what we want. That's why you learn the properties at the end of the day. So then doing that gives us, I'm going to come over here now, x minus 8, and you have to put it in parentheses to kind of keep it together, log of 8 equals log of 997. Now, the x minus 8 here is multiplying the log 8. And even though it doesn't look like it, this log 8, it's a number, just like 5 or any number you can think of. It is a number. It is a number. It's just a weird number. It's a log. So and I say that on purpose. I say that on purpose that it's a number. Why? Because let me take you back. Let's go back in time. When I had something like this, how would I get rid of that 2? How would I get rid of that x? I'm sorry, how would I get rid of the 2?
Divide by 2 on both sides.
Divide by 2. So whatever you're multiplying by, you can divide. Well, this is a number that is multiplying over here. I can just divide by that. It looks weird. Log of 8, what does that mean? It's a number. It's just a weird number. But you got to do it to both sides. And so what that gives us then is x minus 8 equals this thing here. Calculator time. Find the log of 997 and divide it by the log of 8. And notice, what is the base that I used? I used a base 10 so that I could use it on my I could do it on my calculator. 997 log divided by 8 log. And that gives me the value 3.32. Now you add 8 to both sides to finish solving, and we get 11.32. And that's the answer. That's the answer. So it kind of comes full circle back all the way then. So when you solve equations, the two rules are do the opposite, do it to both sides. And when you're in an exponential, when your variable's in an exponent, that's what we call an exponential. The opposite is applying a log to both sides. That's the ultimate of what we're trying to get to here. And the log you use when you do this, the log you use is going to be a log base 10. Why? So that you can do it on your calculator. That's the key. That's the other key. All right. Let's see. I'm probably going to... Oh, there is one exception to that rule. You still can do the log to each side. But when you have an e as your base, the base of the log you want to use is a log base e. Oh, but wait a minute. A log base e, what is that? That's a natural log. And so you can take the natural log of each side. Makes it easier. So this exponent here hops out. So I'm going to come over here. -2, so put it in parentheses, 2x minus 2, ln of e equals ln of 93. But for this part, the ln of e, because the base of the log and the number are the same, that's going to reduce to 1. That's why I chose the ln, the natural log. So the ln of e goes away, leaving -2x minus 2. Now leaving the ln of 93, so go ahead and do that on your calculator. So 93 natural log gives me 4.54. Oh, I'm sorry, 4.53. Add 2. And then divide by -2. So it gives me x equals -3.27. That's the answer. But it's the same process. Just take the log of each side to break the variable out of the exponent position, because we're applying the power rule to break it out. That's where we're at. I'm probably going to waive this last one, by the way. So don't worry about it too much. But let me say it this way. I'm going to keep it assigned. What I'm going to do is in Canvas, I will drop the lowest one, the lowest homework score. So if you don't get to this one or you don't get to another one, I'm going to drop one. But if you do get to it and you get your 10 points, you'll get 10 points and you'll just have another one dropped. So it's to your benefit. If you think you can do this one and you want to do it, go for it, get the points, and I can drop another one later, a different one. So that's how I'm going to work it out. So I'm going to keep it assigned. I'm just not going to, in Canvas, I can drop a lower score and work it out.
Thank you. But for with Hawks, right? It doesn't matter. I feel like you can't really get a low score. You either get it wrong,
right,
or I don't know. You just start over and then you get 0 points for it.
Right.
It's not done. I don't know. It's frustrating.
True. No, I get it.
Yeah. It's like you get it all or you don't do it. like you don't get any points for it.
True, true, and it's based in
Yeah.
part on a trying to get you to a mastery level. Keep you doing it until you're like, oh, okay, finally, I got it. It is
Yeah.
frustrating because you could be spinning your wheels on one or two assignments and just
Right.
it's kind of the way it is. But um, so in essence, if you don't do this one, you'll get a 0, but I'll just drop that 0.
Okay.
So
Thank you.
if you
No, I
didn't want
really
to do if you
appreciate it.
let's say Addie, if you didn't do this one, it's not gonna hurt your grade.
Okay. Okay. Thank you so much.
So we've only got a couple minutes left, but any burning questions?
Um, I guess on just some old things that we had. Before class, I was working on. I'm sorry, I still got that cold. I
Hmm.
was working on a Cartesian coordinate. No, sorry. Sorry.
So 2.1 or 2.R.5.
Yeah, 2.R.5 or something. I can't quite remember. Um, Never mind. I can't find it.
Let's look at this one.
Um, yeah. Oh, okay. I guess with like consistent and inconsistent um systems, like had
System. Yeah, it's a different one.
I didn't have a whole lot of like I didn't have a whole lot of notes for that one.
Yeah, this is a different
Consistent
system.
and inconsistent and stuff.
So let's see. Maybe it's this one. Skip, skip. Okay. Let's do this. Okay. Consistent, inconsistent, dependent. Consistent,
Yes.
consistent means one solution. That's what that one means.
Yeah.
Okay.
Okay.
So,
Um,
in what context are you is it a problem like this or is it when you have a graph?
with a graph.
Okay.
Yeah. So
When you
sorry.
No, when you have a graph, what does it mean? Anybody can shout it out. What does it mean for a system to be consistent or inconsistent or dependent? I mean, you can take any one if you want. So,
Yeah, I was looking through my notes, but I don't think, again, I'm a bad note taker. So
oh, that's
I
fine.
was trying to write everything and
Yeah. So, a consistent system is one where there's only one point of intersection,
yeah.
only one
Okay.
solution, one point of intersection. It's consistent. That's it. One. An inconsistent system is when there's no solution. So remember in systems of equations, we're looking for the point of intersection. So if it's inconsistent, there's no solution, meaning the lines never cross, meaning they're parallel.
Yeah.
Parallel. So inconsistent means parallel. And dependent means that they hit at every spot. And if they hit at every spot, the two lines are actually the same line.
Okay.
So 1 point, one consistent, one solution, one point of intersection.
Okay.
Inconsistent, no solution, no points of intersection, parallel. Dependent, one line, infinitely many points, infinitely many solutions, because they intersect everywhere.
Yeah. Okay. And so if it is consistent and that one solution would be the
Yeah.
point where they meet.
Yes.
Okay.
The solution is the point of intersection.
Thank you.
The ordered pair that goes with it too.
Okay. Got you. Okay, that's gonna help a lot. Thank you.
Okay. Anybody else? So,
I have a question.
uh-huh.
Okay, so we have until the 8th to be able to finish up any assignments that we have that are due, right?
Yes.
Okay, and
Let's look at
and
that.
then after that, what day is the final that you're planning on?
Take it any time next week, Monday through
Anytime?
Thursday. Yeah.
Okay. And then we only get the one try for that,
Yes.
but it's not on one of those are you doing it on Hawks?
Yes.
Okay, so it's not going to be one of those where they have to like screen monitor you and all kinds of other crazy stuff.
I mean, I could set. I'm not going to set that.
Okay. I just wanted to make sure.
It's like if we use Desmos or something.
That's what I wanted to ask. Because
Say what?
it'll track what sites you're on, so I didn't know if we were using like Desmo on the other side, and stuff like that.
I'm not going to probably give you anything that would require Desmos.
Okay.
So like it'll be stuff that's doable. Let me see. I'm trying to
Stuff from the beginning of the course.
say it again.
Stuff from the beginning of the course.
It will be cumulative, but I'm not going to probably give you a basic fraction because
Yeah.
part of your work of
Okay.
doing these problems, you need to know fractions. So I can
Yeah.
so the way that I'll do some of the earlier stuff is it'll probably be incorporated as part of having to solve the later stuff. So like solving linear equations, I may give you one, I don't know, but I don't have to because I can incorporate all that into stuff we've been doing
Oh, for
here.
sure. Yeah.
Yeah.
So probably a good measure would be anything from test two forward. Test two, so
Okay.
factoring, rules of exponents, graphing, systems of equations, all that stuff forward. Because
Okay.
that's sort of new, that's sort of independent lessons, but they still rely upon your initial stuff at the very beginning. So
And
that's
we
that's
probably
how I
could,
capture the initial beginning stuff.
Gotcha.
yeah. And we
That's all I
should
want to
probably
know.
just have like what I'm going to do is write out the list of formulas. Like this is the area of a triangle and stuff like that. Because that's what I often find
Oh,
myself looking up during
yeah, there
homework.
may be a couple
I
of
just need to sit down and just write the formula.
yeah, there may be a
Oh,
couple of geometry ones, but not many.
Okay.
so the 8th is technically so the 8th we have until to turn in this stuff, but we could take it anytime from the 9th all the way through. But what day is the last day that we meet? Is today the last day that we meet?
Meat, yes, meat, yes.
So this is the last web thing
This
that we're
this is
doing.
it. Yeah, this is the last new material because
Oh,
we don't. I think you have finals in your other classes too next week, right?
Just have this class left
Oh,
for me,
girl.
right? I had a lecture class and I was like, "You giving a midterm or a final?" And she goes, "Oh no." I said, "Yes, done."
oh, you don't have a final at all?
I don't have a final at all.
Oh my
I just
goodness.
have yours.
Yeah, majority of my classes in this week too.
Yeah.
Okay, good. So
And
I'm not.
no.
Yeah.
I
That's
appreciate that,
English.
Jordan, because I was a little you could hear it. I was getting unsure.
Well,
We have
I do have a question because, like, my English professor, he basically, we haven't had class all week, but he's been there. If anybody need anything or have any questions, he's been on there. You can just go on there. But he quit lecturing last week.
Oh, okay.
And so I don't know if he's going to be there. Well, I don't think he's going to be there Monday or Wednesday of next week either
Okay.
because our, our,
is
our stuff is due, I think, on Monday night.
is the 8th a hard deadline, or is it
Yes.
technically before the 12th?
I think it's. Let me see. I'm trying to.
I think the other day you said when you looked it up, it said the 12th
I did.
because you still have to put grades in.
Yeah, you can work on until the 12th. I'm going to make sure it's open. It should still be open through then.
Okay.
Uh, I'm not going to go in there because once I start opening reports, you'll see your grades, and I don't want to do that. So
Did you already post the final exam on Canvas or
it is not visible to you yet. No.
Okay.
okay, I just wanted to make sure.
Will it be
Um,
timed?
It'll be yeah. You'll probably have like 90 minutes or 2 hours. I mean, I'm not going to make it so undoable that
Okay.
you'll set aside 2 hours. It'll be sufficient.
Okay.
It'll probably be at most 20 questions. It'll be like two tests. Think of it that
Okay.
way.
Gotcha.
At most 20 questions, maybe not even that many, 15. Kind of that's what I'm thinking.
Yeah, 15 sounds good.
Depends how you're feeling, right?
Well, it's kind of it. What the way I look at it is, it tells me whether it's a low, medium, or high difficulty.
Okay.
So I try to get a good mix. I'm going to probably throw in one difficult, maybe two difficult, and then the bulk are going to be medium, and then one or two low. So it's kind of just trying to get a mix. But I really what it is I'm trying to make sure I get coverage. Am I testing on everything that needs to be tested
Yeah.
on? That's the key. That's how I look at it. I'm like, okay, I go through and I look at the lessons. I'm like, okay, we were doing this, 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 this. Let me get problems. And so actually that function problem, that function worksheet we did the other day, that's a good one because um,
Yeah.
it tests on a lot of things. Now, that was problems I created on my own just out of my head. Hawks
Mhm.
allows me to do it. It does, I don't have to think of all the numbers. It just says, well, here's the problem type, and I'll pick and choose. So, anyways, I
Okay.
pick and choose problems to give me coverage as to the material that's done. So it'll it'll run like the other test in the sense that it will be doable. I'm not here to break you. I'm here to test you. I'm here to see what you know. And this is not going to be one of those things like, okay, you made it this far. Now let's really, stick it to you. That's not my style.
Right. Right.
Uh,
Yeah.
this is not the forum for that. Uh, if you were in law school, it would be the forum for that. So,
Yeah.
sorry,
Yeah.
I hit something here and I'm messing up. Anywho, any other questions?
I forgot to turn in the last one on the other class. I forgot to turn in the paper that shows how we did everything. Can I turn that in to you
Yeah,
tomorrow morning? I
yeah,
have way more time tomorrow
turn it
morning.
in for sure. Yeah, so in the other one too, that's a good reminder. In the 88, you're going to get a grade in that too.
Yeah.
Make sure you get everything in, and you should be 100. It's kind of one of those things. It's not designed to break you at all. It's supposed to be one of those things that's pure review, if you will.
Yeah.
So make sure you get all of those in, even if it's late. I don't mind. I'm not going to deduct.
Not a question, but I just want to say something.
Uh-huh.
I just want to say we really probably not everybody, not mainly probably everybody. We really appreciate all you've done
Yes.
in this class for us.
Yes.
Yes.
Yeah.
Thank you.
Between helping us, being there, understanding, like not all teachers do that, and we really appreciate it for that.
Okay,
Yeah.
wow, I appreciate that. Appreciate the kind words. Yeah, no, I feel fortunate that math has always been something that has been natural for me. But
Yeah.
my very first student was my wife, who took. We both went to UL, and
Yeah.
she took college algebra 5 times, and
Oh, yeah.
so I remember seeing this
I
literal
agree.
tears coming down her face when she would kind of work through this, and that she was doing fine on the test, but she was so
Right.
so wrought with anxiety about it that it kind of
Yeah.
interfered with her learning. And so, a lot of the things I do here were born out of that experience, which so really, if it hadn't been for my wife, I probably wouldn't have the patience level. I'd be like, well, why aren't you getting this? Sort of
Yeah.
thing. So she gave me
No, I so
perspective
appreciate
into
that.
the other
Well,
side, into the
tell her we said thanks.
yeah.
Yes.
Yeah.
I was holding back tears earlier, so I can relate.
Oh yeah, no, I feel
I was
you.
trying to talk and I was like, so thank you.
No. And so that also gives me the sort of the flexibility because I do remember in when I was in graduate school, I taught at UL. I went to graduate school there, and we had to teach this level class. I taught the remedial and in the college algebra, and there were some sticklers, some graduate students who were sticklers, and I was like, why are you pounding them? I take a pragmatic approach to some things, kind of like this. There's a lot of things I don't remember and I don't use, but you go through it because that's a hoop you have to go through to get your
Yeah.
degree and your larger goal. But does that mean do I need to pound you with it? The answer is no. These concepts here are not meant to be remembered for the rest of your life. I have forgotten almost everything from graduate school. There's a lot of math that I learned that I no longer know. The point is not to remember it. The point is what? These are tools and skills that you're learning. Maybe you're not going to solve a logarithm question ever again. You may never see another log. But the point is what are you doing? You're kind of giving yourself some mental gymnastics, and
Yeah.
you're manipulating. That's what math is really in the core, is what I look at it. It's manipulation, and you're manipulating with your brain in a lot of ways, which is a tool you'll use, which is a skill you're going to use in many ways. So it abstracts your thinking. It allows you to sort of work with things, and you get sort of a uh, not a number sense, but you get sort of a sense of like, well, hey, there's interaction here. How do things interact with each other? And
Yeah.
so that's the larger skill. That's why I'm not there to kill you with these problems. Do you know it? You got the skill, at least for this term. But the point is by learning the skill, something's new in you. That's the whole point. And anyways, that's my approach.
Yeah.
It's a
Yeah.
more of a pragmatic
My
approach,
training's
not a
training. Yeah.
this isn't the end for you. This is not the core of your learning. If you were math students, we would be hitting it hard, uh, much harder. Let's say it that way.
Yeah.
You're saying I referred you to to like the SOCC teacher, and
Mhm.
so if you get more students in the end, that's why.
Oh, there you go. There you go. I
Yeah.
appreciate that. Oh yeah, I appreciate the talking up. No, that certainly helps because it's my first semester here with I taught with SLCC. Y'all don't know this, but back in like 2001, so I forget. It's been a long time. 2003. That's when I taught. So I was with SLCC. They were at an old building before. So it's kind of nice, but the staff is new, the administration's new. So if I appreciate the comments because I think it helps. I'm new to the school, so it helps, with me. So I appreciate that very much. I always, if you can tell, it catches me off guard. I don't get to see evaluations and all that stuff, so I appreciate that very much. Uh, in the coming days, you may have questions. Feel free to, oh, let me do this. Feel free to reach out. You can do it through Canvas inbox, that's fine. But here's my phone number too. If you want to shoot a text, it's fine by me.
Okay.
I'm sorry you have to put in all my grades individually, by the way.
Uh, oh yeah, no,
Sorry.
that's fine. That's fine. It's pretty easy. It's zeros and hundreds, and so
Yeah. I'm
so
gonna finish up as much as I can, but yeah.
I'm not too sad about it. No, but I'll tell you why it happened. Do you know? Did
I know why it happened.
Jackie, you used a different account or something like that, or you bought?
I logged in on one and then I linked it with the other because I had my app wasn't working. I had to go to
Yeah.
IT and do a bunch of stuff. So that's why. I know why it got messed up, but I couldn't fix it because it wouldn't let me fix it. It wouldn't let me like log out of it and put it in the other system
Oh,
because I had already logged in and it
I
had
was
already
surprised I
linked.
couldn't link it. I thought I
Oh, it wouldn't
could
let me
like
link.
just say link it
Yep,
and sync it, but
it wouldn't let me either. I
yeah,
tried logging in from this system and it was like, yeah, that's funny. No.
yeah, yeah.
So
Dream on. Yeah, I
yeah,
hear you.
basically. But I was able to do it. So, like, I was still able to do the work. So, as long as I
Yeah,
can get credit for it, I'm fine.
right, right. Yeah, it's just we have to wait till the end. I'm gonna eventually stop the sync, and it'll cure. So
Yeah,
that's how it's gonna fix. I'll eventually break the link, is what I'm saying. Once Thursday comes, I'll break the link, and on Friday, I'll be able to enter everything, and it'll be fine.
And
sounds great. So, we have till
Okay.
the 12th to turn in the rest of our work.
Yeah, is that it? Is that a week from today? Yes.
Let's just say
Yeah.
the 11th. Make sure it gets
I
there.
was about to say the 11th. Put
Uh,
everything for the 11th.
There you go. Well, yeah, yeah. However you want to manage your time, it's fine by me
Yep.
too.
And I just wanted to say thank you also, and good luck to everybody. And it was nice meeting y'all. And I hope I didn't, hog the class too much, but this was my first class in 30 years. So
Me too.
all your questions.
Me
what's
too.
that?
No, you didn't. You good.
No, yeah, no, no. I agree. It's good to have questions because I'm sure that you raised a question. I'm sure someone else had the same question somewhere along the way. So,
Well, I have a 21-year-old, 21-year-old graduating in May from UL.
mhm.
And she was like, Mom, you have to stop. You can't keep asking all the questions all the time. I said, well, there might be people that want to ask, but they don't want to ask. She said, no, don't do that. I'm like, so then I said, okay, well, then I'm really going to do it because you're telling me not to do it.
Oh yeah,
There you go. I'm
But,
glad you did because I always appreciated questions.
yeah.
well,
I
thank y'all.
find I find this the questions. So, as a lawyer, that's all you do is ask questions. But the point is that you may not be thinking of the question, and then someone else says it, and you're like, oh yeah, I have that question too.
Mhm.
So I always say, ask your questions because people may not realize they have the same question until someone else asks. Is like, oh, okay, yeah, that's what I was unclear on. So
Yeah. And thanks
no
for all your
problem.
patience too.
Yeah. Oh yeah, for sure.
Well, good luck,
All right.
everyone.
Good
Okay. Yeah.
luck.
Happy studying. Merry Christmas. Happy holidays. New Year's
Merry
coming up and Mardi Gras next year. So
Yeah.
again, good luck. I know this is one step on your path, and I wish y'all great success as you move forward.
All right.
Thank
Thanks so
you.
much.
Thank
Alrighty.
you.
Okay.
Bye, Professor
Bye,
Dave.
I'll
everyone.
load this one in
Bye.
the other
You
video
only teach algebra?
here soon. Say it
You don't
again.
teach no other, you don't teach any other math classes?
Well, maybe so. I've put my hat in. I teach statistics. I have a lot of statistics background,
Yeah.
so maybe
I
I'll get
need
a statistics
statistics.
class.
Oh,
Yeah.
I might have you in statistics.
I'm not trying to get to your statistics.
I
Let's say
might
I
have
don't
you in statistics.
let's say I don't have a class yet. Maybe one will open up for the spring. I don't know yet, but
Okay.
I may see you in statistics. That's one of my that's I like algebra and I have a good feel for it, but statistics is really what I really like.
I
So
don't
you're
have.
not sure what you're teaching in the spring yet?
No, yeah, not yet.
You
I don't
should
know.
teach statistics so we can come back.
There we go.
Yeah,
I'm
Right,
open for it.
I'm
right.
actually taking that in
But let
January.
us know before everybody so the class doesn't fill up.
There we go. There we go.
I have that. I have statistics in the summertime, so you have enough time to get in.
Okay, there you
No,
go.
I'll take mine next month. Then January.
Say it again.
I'll take mine in January next month.
Oh yeah, yeah.
Yeah.
Statistics is fun. Let me give you a little preview. By the way, you know all the math you need to know for statistics. If you can do this, you know enough math. Statistics is not about math. It's following a recipe, steps. Step one, step two. It's a little more. In some ways, it's a little more kind of easy to follow. The problem with statistics and what makes it difficult is not statistics. It's a new language. You got to learn new words, and new words mean new processes, and that's what drives people crazy. It drove me crazy. But once you, and it's sort of weird. It is weird, and I'll give you a little flavor of it. When I was in graduate school, statistics was its own separate department. There was really no crossing between the mathematics graduate students, and the statistics graduate students. They didn't really cross paths. It's really separate and apart from all this. So, but all you need to know for math is add, subtract, multiply, divide, and take the square root. That's all you need. You're not going to do all this other stuff. But it's a lot of data manipulation and learning how to manipulate data. Uh, and it's cool. I like it a lot. But um, it's just a little different. It's just a new language. So once you get over the fact that, oh, it's a new language, you hone in on the words. The words mean the process, and then you can start building from there. So when you take statistics, look at the word. The word means something. It means here's what you have to do. Things like that. That's what I was
Okay.
trying to do with our class. When you see simplify, it's this. Evaluate, it's this. Solve, it's this. It's the same sort of thing. When you see a certain word, it tells you what the process is going to be after that.
I'm ready for it.
Yeah, it's cool. It's fun. It's very fun. And that statistics, I'll say this: you can use that more in real life and in your everyday life, and you will remember it. You'll see because I mean we just finished an election, and you saw the political polls and all that stuff. That's obviously it's riddled with statistics, but there's more meaning in it than you realize. We all get the sense, okay, yeah, Trump, whatever, Biden, whatever. Okay,
Mhm.
but there's more to it, and it's pretty cool. The news doesn't really do it justice. So, anywho, I could go on. I'll talk another 4 months about that. All right. Well, good luck, everyone, and don't
Thank
hesitate to
you.
reach out if you have any questions. I'll be glad to lend a hand.
Okay,
Thank you.
thank you.
All righty. Okay. Y'all have a
All
good one.
right. You too.